All right, here we are with 11.4, multiplying and dividing rational expressions. The good news is we're just going to be using things that we've learned before to make this easier. It's just putting a whole bunch of ideas into one big section. So starting off with our learning goal, I will multiply and divide. Rational expressions. Pretty straightforward again. So, starting off, something to just keep in mind, remember when we're multiplying fractions, if our fraction is a over b times c over d, to multiply those, we multiply straight across. So it's top over bottom. Remember that it does make it easier if there are common factors between the numerator and the denominator. It's easier to simplify and divide those out first before we do the multiplication. And then remember, if we have a over b divided by c over d, if we're dividing fractions, that's the same as multiplying by the reciprocal. So multiplying by d over c, or ad over BC would be our final answer. And again, if we can divide out common factors in this step, that makes life a whole lot easier for everybody. Okay, so our first example, we're going to have 2n minus 1 over 4n to the 5th times 2n cubed over 3. So something to keep in mind here is that this 2n minus 1, I can't break that 2 out of there at all. If you want to split something up, you have to be able to factor it. And in this case, this is in factored form. There's nothing that can be broken up. So I can't take this 2 and this 4 and divide those out because I have that minus 1 stuck on the end. So instead, when I look across, I have a 2 here and a 4 here that can simplify. So 2 goes into 2 one time, 2 goes into 4 twice. And then I also have an n cubed up here and an n to the 5th down here. And if you remember your rules with exponents, basically I have 3 n's up here, 5 down here. I'm going to be left with n squared in the bottom. So the n cubed will divide out, and this will be n squared because 3 of the n's were divided out of the n to the 5th power. So if I go straight across the numerator, I'm left with 2n minus 1 times 1, and my denominator is 2n squared times 3. And then from here, obviously when I multiply by 1, nothing's going to change in the numerator. In the denominator, I have 2 and 3. That makes 6n squared. And I know that this really can't be simplified any further because I did this first step of dividing out all of my common factors. The next example is k minus 3 over k squared times k plus 2 over k squared minus k minus 6. And now it might not seem like something you need to do, but we actually are going to want to factor this. So again, if you are not solid on your factoring, this is definitely going to be the chapter where you get that figured out. So my first fraction is going to stay the same. There's nothing that can factor here. My numerator stays the same. I need to find two numbers that multiply to give me negative 6. So they're going to be opposites. And I have a negative middle term, so the bigger number is negative. It's going to be 2 and 3. So from here, oh, interesting that that worked out the way it did. I have a k plus 2 in the denominator and a k plus 2 in the numerator. I have a k minus 3 in the numerator and a k minus 3 in the denominator. So I'm left with just a 1 in my numerator and a k squared in the denominator. Let's look at excluded values for a second. I actually forgot to go back and do that on this one. For this guy, if I look at the original problem, my excluded value would just be n equals 0. And when that gets all simplified, I can see that that stays the same. So the excluded value there is n equals 0. If I were to look at the excluded values here, though, in this case, I have n equals 0 from this k squared. But once this is factored, I can see that my other excluded values would be -2 and 3. So I have 3 excluded values, even though when it's actually multiplied out, I only have 1 over k squared as my answer. So just like in the last section, it's important that we go back and check the original problem, or the factored version of the original problem, to look for those excluded values first. My next example is division, which is really just multiplication, because division and multiplication with fractions, or with rational expressions, are basically the same thing. So let's start off by multiplying by the reciprocal. So this is going to be equivalent to d plus 6 over d squared times, and then I flip this fraction over, so d squared over 2d plus 12. And now this is just multiplication like we were just doing. So the first fraction is going to stay the same for now. There's nothing that can be factored. That's going to stay d squared, but I see that I have a 2 that can be factored out of both terms. So I can pull out a 2, and I'm left with d plus 6. And of course that should make sense because I had a d plus 6 up there, so you know these problems usually work out nicely for a reason. So from here I'm going to divide out my common factors. D plus 6 in the numerator, d plus 6 in the denominator, d squared in the denominator, d squared in the numerator. I only have a 1 left behind in the numerator and only a 2 left behind in the denominator. So that simplified super nicely to 1/2. But go back to your excluded values, and d cannot be 0. So remember that my excluded value is d equals 0. So just keep that in mind. Okay, my last problem looks like it's different, but turns out we do it the exact same way. We're just going to put this all over 1, and then it's a fraction divided by a fraction, or a rational expression divided by a rational expression. So when I do that, I'm going to change to multiplying by the reciprocal. So a squared minus 16 over a plus 3 times 1 over a squared plus 7a plus 12. So I just turned that polynomial into a rational expression by dividing by 1. Next I need to factor. This is the difference of squares. So that's a plus 4 times a minus 4 all over a plus 3. And then this right here will factor to, let's see, I need to multiply to give me 4 and add to give me 7, so that one's pretty easy. A plus 3 times a plus 4. Now if you see that a plus 3, you're like, oh, wait, they're on the same side. That's not helpful at all. So those actually cannot factor out. However, I do have an a plus 4 that's being multiplied in the denominator and an a plus 4 that's being multiplied in the numerator. So those can divide out. When I go straight across then, I have a minus 4 times 1, which is just a minus 4. And then I have a plus 3 times a plus 3. And I can write that as a plus 3 squared. So from there, I'm done. That's how this division is going to work. So dividing by a polynomial is really not any more complicated than the stuff we've already been doing. And that is actually the last problem, or the last example. So flip to page 572. And your homework is numbers 1 through 3, 5 through 21 odd, 22 through 26, and 27 through 30. So hopefully once you get the hang of all of the factoring, these will go pretty quickly for you.